Okay, guys, can you hear us? Okay, awesome. So if you stop hearing us, just give us a shout, please, because we don't have our StreamYard master today. So we on our own. I see a couple of people already joining. We have 13 people watching. This is broadcasted to YouTube. Okay, just let me... yeah, I think Tomek wasn't actually saying anything. No, so it's me talking.
Yeah, hi everyone. Hope you can hear me as well.
Awesome, great. Oh, we see Maciej. So Maciej, we are missing you really, because this is pretty easy to use, but it's the first time we do it, and you've been doing a great job. Okay, guys, welcome to I think the 9th edition of GDG Cloud Bydgoszcz, but we joined our forces with GDG Warsaw, so we have this event together, and we put it together as GDG Cloud Poland. If you're from any other GDG in Poland and would like to join us on those webinars, please let us know, because we would like to meet you, and probably we can make even more sessions, make them more often. We try to do it every 3 months, but it's quite challenging these days, especially end of the year. Probably all of you doing some sort of development now that you're finishing probably your releases, so the schedule is pretty tight. Okay, a couple of words, because I see people from around the world really. So please say hello in the chat. We would really like to know where you guys from, so we can greet you in person. So just let us know where you guys from. We have quite a nice lineup today. So first, I'm going to talk with Tomasz Porożynski. We're going to talk about Terraform, how we use Terraform in Antos, actually, how we use it to build infrastructure for our customers. And then we're going to have Wojciech Marusiak from Google, who will be showing us the new offering from Google, which is VMware Compute Engine. Pretty exciting thing. AWS had it already. Azure had sort of a similar solution as well, and now we have it from Google. It was announced a couple of months ago, I think like a year. I heard about this like a year ago, I remember. But this went live, so quite exciting. I'm really excited to understand what Google and VMware are going to offer, because that was really lacking in the portfolio of Google. And of course, as I promised, we have some contests today. So we have those fresh books. They came to me a couple of weeks ago, all sponsored by Antos. So thanks, Antos, again for this. We have a couple of those books. We actually, for the next, it's worth coming to the events, because for the next couple of events, we're going to have those books giveaway. So listen carefully, because we're going to have a couple of questions, actually 3 questions after our speeches. After the speech of Wojciech, we'll ask 1 question about Terraform and 3 questions about VMware Compute Engine. So, the first person that answers on the chat is getting the book, of course, if they answer correctly, right? Would it be possible to see the recorded session from our meeting later? Yes, of course. We're going to publish it. I'll probably need Maciej to help me out how we make it listed on YouTube. It's definitely going to be there. So yeah, you will have access to it. No worry, Pavel. Okay, so where do we have people? Oh, we have Czechoslovakia. Okay, awesome. We had London. We had Warsaw. Oh, do we have anyone from Bydgoszcz? Maciej from Warsaw. Situation stable.
Yeah, actually, I'm from Bydgoszcz, so hello.
Good stuff. And guys, another thing that we want to ask you, so let us know which topics are interesting for you. I'm trying to set up a session in January. It will be very interesting. I hope our speaker will accept the date. If not, we will switch it because our next speaker is going to be from Japan. So there will be really cool solution. He's doing really cool stuff. I'm going to share a link with you later on. He's doing ML on edge, so he's training models, putting in on edge devices, and doing really cool stuff with it, like tracking objects, like responding to voice commands without really using ML models hosted on Google. It's on those really small devices where you install this model. So quite amazing stuff you could actually do yourself within a couple of hours. I'm really excited for that. Let me know if those ML topics are interesting for you, because I know we've been concentrating on Kubernetes a lot recently and infrastructure basically. So let me know if you're interested in the ML topics as well. Okay, and with that, I see actually a couple of people coming with some emails. Let's make sure that we can actually recognize you for the contest, at least for the contest part where we're going to draw the books. Sorry, we're going to ask you the question because we really need to, understand your identity. So please help us with that. Okay, and I think we have actually 10 minutes to go with the presentation, but I see there are not many people coming in. So I suggest we just start with the first presentation, then we will have a small coffee break before Wojciech arrives, and around 7 o'clock p.m. Polish time, we'll start with the second session. Okay, cool. So let me share my screen. I have my second laptop in here just in case you guys are writing to me, because I won't be seeing anything. So we will start with the presentation on Terraform. So give me a shout on the chat if you can see it correctly and you do actually see my screen now. I think you should. Let's hide this. Tomek, you can see my screen? You can hear me?
Yes, I can see your screen and I can hear you.
Okay, awesome, guys. So today we're going to talk about how you build your infrastructure with Terraform on GCP within a couple of minutes. And I'm literally saying a couple of minutes because there are so many ready blocks that you can use to build GCP that it actually, with the basic understanding of Terraform, you can run it within minutes. What is the agenda for today? So we will make a small introduction. We would, as I said, I would like to learn about you guys as well. Please put whatever information you want to share with us. Especially, I'm interested where you guys from, and whether you're a developer, whether you deal with, whether you're a cloud architect, what you do in your work every day, because that's really important for us who's our audience. It's a shame we cannot meet in one place, but hopefully in this way we can learn about each other. We will have a look at what is actually Google Cloud. What would you use Google Cloud? I know we have a couple of people that probably are here for the first time. I'll try to be fast in this, but just to let you understand why you should be using Google Cloud. We'll learn what is infrastructure as a code. We'll learn how to build things with Terraform, how to test Terraform, how to generate Terraform templates automatically, and we'll have a short summary. Okay, so who we are. Actually, myself and Tomek, we're working for Atos. Now it's Atos R&D, Research and Development. We actually have presence around all the major delivery centers. We are only major cities of Poland. We also are in other cities. We're actually in Gdańsk, but we have separate divisions of of Atos, but this is basically the global services are in those locations. We're over 1,000 developers in Poland. So in a way, we do some development, not only on Google Cloud, obviously, but on any cloud. We do also produce programming on top of managed cloud services that we do, managed services in general that we do. And we are around 140K experts worldwide. So it's quite a massive footprint. Experts around the world. I really love about this job that we can, talk to people from around all different cultures, exchange the experience. And what we do with Google Cloud, actually, this might be very interesting for you. So probably you know the bare metal solution service in Google. So this is allowing you to provision physical servers within Google Cloud platform. So this is what Atos is actually delivering. So we are the hardware that's behind and automation that's behind. This is actually developed by Antos. And also, if you think about Oracle on GCP, which is also using bare metal, this is also an offering that Atos is working on and providing to you through Google Cloud. Okay, a couple of words about myself. So, I try to share my knowledge as much as possible. So, I'm leading this GDG Cloud Bydgoszcz. I work with all the guys from Bydgoszcz and also Warsaw. So I like to say hello to Maciej, also, and all the guys from GDG Cloud Warsaw. I'm a graduate of Technical University of Łódź. I spent all my life doing IT. I'm currently a lead architect in Atos. I'm actually working a lot of Terraform, so I'm working one team with Tomasz. We're producing landing zones. We're producing a lot of automated services based on Google Cloud Platform, so we can enable our customers to start deploying the workloads, whether it's IaaS or containerized workloads into GCP, and to make it safe and streamlined. As you see, I'm a certification junkie. I'm doing all the certificates possible. And trying to help people to certify as well. So if you have any questions, I actually suggest to go to my website first, gcpfellow.com. If you don't find the information you need, give me a shout, because I would like to post on it so more people can use it, and so that I don't answer everyone, each person. I would like to have a really nice page where you can find all the information you need to take the exam and successfully pass it, right? So I'm trying to give you as much tips as possible. I'm not telling you what questions you will have, but rather pointing you towards the information where you can get the information to pass the exam. And, on top of that, I try to have my personal life as well. So I love windsurfing. I love running, getting things done, but I also, love cooking. So those are the things that I do in my private time and try to find time for it. Tomasz?
All right, so I'm not that good at cooking, but I love eating. So maybe we can connect those two. As Konrad already mentioned, I also work at Atos. I have around 10 years experience with the storage engineering background. So IT operations is my stronger side. However, I'm doing my best to learn how to develop as well. I'm running a technical blog after work, storagefreak.net. Some of the topics are storage related, but some of them are Kubernetes and cloud-based related topics, as well as YouTube channel. Not that many tutorials, however, I think there are like 20 of them. You can check that out after that. Besides that, I like traveling, snorkeling, reading a good book, and learning new stuff as well. That's why I really love those topics around cloud, because there's always something new to learn. All right, thank you. Let's move on. Okay, thanks you. And again, we want to learn about you a little bit more. So give us a shout. Where are you guys from, and what's your occupation? Okay, a small introduction to GCP. Really a small thing. The cloud definition. The definition is that actually, the cloud is on demand, self-service. It has the broad network access, rapid elasticity, and measured service. But the most important thing for me is the API-driven architecture, right? So we need to be able to provision our access, our resources in GCP
using API. And in this case, we will be using Terraform. So that was actually differentiating true cloud from hosting, right? So some hosting actually do have APIs as well, but you should be able to programmatically request your resources and do it in a streamlined way. And this is what GCP is actually providing you, right? You have multiple public clouds, AWS, Azure, obviously GCP, you have Alibaba Cloud and Oracle Cloud. But, as you see, GCP is getting more and more traction. You see how much Google is investing in the development and also in enabling. So if you want to start learning some of the clouds, I think really, honestly, starting to learn GCP is the easiest way to go. I mean, there are so many free resources to do that. You can actually sometimes even get free vouchers for partners. It's the easiest way to start your cloud journey. And I really strongly feel that Google is doing it the right way, making it easy to learn. Okay, why would you care? Especially in Poland, right? I'm not sure if you guys have seen that, but we've been waiting for a while already. There is a massive investment in Poland to develop Google Cloud. And actually, if you know, Kubernetes is actually being developed in Poland as well. So GKE service, Kubernetes, also GCE, but there's so many services of Google Cloud actually being developed in Poland. So it's growing massively. And we're actually going to have our region, right? The question is whether it's 2021. I bet it is. The announcement was, I think, 2019. So actually, this is going to be first massive cloud provider, one of the biggest hyperscalers that's going to have a region in Poland, right? So I'm really expecting that it will happen in 2021. As probably no one can promise that, but it's going to take around 2 years from the announcement to get this done. Yeah, and this is going to be a major thing, really, guys, because this region is going to work for all those Baltic countries around. So it's a massive thing for me. Okay, another thing, why would you want to run your workloads on GCP? So definitely Azure, AWS is really good in especially Azure in enterprise. Google is really catching up, but there are a couple of things that Google is really good in. So if you have use cases for using cloud native, for using Kubernetes, GCP is definitely the most advanced service there. So actually Google invented Kubernetes, right? And they outsourced it, and they actually I believe one of the biggest committers to Kubernetes. We have other companies doing it as well, but they've been there from the very beginning. Yeah, they understood the philosophy and they bet totally on it. So if you look at the services in GCP, we started with GCE, you had application engine, and now you have Kubernetes, and obviously you have function as a service. But what Google is doing, and what I really see, is that all those services on GCP, well, it's all those services you have, EAS, PaaS, and function as a service, you have it in almost any cloud. What's differentiating Google is that they actually try to do all this on Kubernetes. So it's actually can be run. So let's say Cloud Run, right? You can take Knative and run it anywhere where you have Kubernetes. Kubeflow for machine learning, you can also deploy it anywhere. But Google also they build their managed services on top of Kubernetes open source software. So the basis is Kubernetes. Then they build application on top of it that allow you to deliver PaaS, to deliver ML pipelines, to deliver function as a service, or deliver serverless basically on top of Kubernetes. So this is all very well integrated, all well thought, and I strongly believe that actually Google is a couple of steps ahead of the competition, right? Because even I see that if you want to run, there are not even some offerings for Knative or serverless on Kubernetes. I might be wrong on AWS and Azure. So if you are all Kubernetes, you think about being probably, people might think multi-cloud is not the best, really a true multi-cloud where you can run your workloads anywhere is not for you. Maybe it's too big investment, but in the future, this will really work with Antos, with the way how Google allows you to deploy Kubernetes in different clouds, and on-prem doing a hybrid cloud as well. So this is really strong thing there. And you obviously have machine learning. Google is really good having all those data sets that they gathered for years. The machine learning model. I think it's a massive boom recently where you get more and more ML services popping up in Google, and they're actually trained models or things that would help you to build the models. And actually, it allows you to do the whole life cycle from data gathering to data processing, creating your model, saving the model, and also observing if the model works right, and then pushing new models to production. So I think those things are the most important, right? If you want to run Kubernetes, if you want to do data processing, and you don't want to do ML, definitely Google is for you. Okay, so I hope this wasn't very much a sales speech, but I just wanted to let you know what are the strong areas, yeah? And now we can start with what is actually Terraform, and what is infrastructure as a code. So imagine you start from day zero, you start to deploy your workloads to GCP, and you do it from user interface or using gcloud commands, whatever you want to do. But then you realize that your environment is growing and you're losing the control of it. Yeah. So if you're developing your code and you have your code for your application, you store it, you version it, you do the whole CI process on it, why don't you do the same with the infrastructure, especially for large enterprises where you want to have a streamlined process? Why don't you treat your infrastructure as a code as well? So what infrastructure as a code allows you is to use a declarative language and create templates for your infrastructure. Yeah, it would decrease your cost of developing, deploying the infrastructure all the time, and designing it again and again. You have it all defined in a code, and you can deploy to streamline the deployment. You obviously reduce risk because of it, so you can review the templates, you can version them, and before you push them into the production, you can have pull requests. They can be reviewed, and it can be some sort of an approval process. Yeah, and you definitely deploy faster. So these days, we can within an hour we can deploy a whole customer with all resources and a lot of things, like a lot of services around it, yeah, related to reporting, integration with ITSM systems. So you can actually create an enterprise solution, deploy an enterprise solution on GCP in an hour or so, right? And you can streamline it. So it's all about templating and making sure that you have control over your environment. And what is Terraform? Terraform is actually an open source infrastructure as a code tool. Yeah? So you have basically access to it through. You can simply download it and run it without no cost. It's developed by HashiCorp, and it's using HCL language. So it's basically a declarative language, very easy to learn, very simple. Actually, I would say that you should learn by doing. So just download some templates and start playing with it. And that's actually how I started learning Terraform. And one important thing is that actually the providers, so like the library for Terraform for a particular endpoint that you want to automate, those are created by the providers themselves. So it's not, maybe in some cases HashiCorp is doing it, but actually the providers are investing their money and they're getting their developers to work with Terraform. They are creating those providers for you. And so actually you receive, and now as Terraform is getting more and more, it's getting more and more popular, the providers are putting more and more money into development, so you have all those templates up to date. So when there is a new service, actually I see from Google, when there was a secret manager, the module for secret manager has appeared. The provider for the provider has been updated with the modules for secret manager. Okay, and you obviously have alternatives, right? So you can use deployment manager, which is actually sort of a best practice right now from Google. But I see that the customers want to use Terraform because Terraform can be used for multiple clouds, right? So it's very often happen that you might have a GCP footprint and Azure footprint, right? And you want to have a single tool to deploy to both those clouds. Then you have Ansible. Ansible is obviously a great tool for configuration management. It's generally great tool for automation, but at the moment I don't see so many modules available for GCP. But I know that Google is going to put some effort to update it. But for the moment, Ansible is actually not, for me at least, it's not an alternative for Terraform. And finally, something really interesting that you should have a look is Antos config connector. So actually, it's a small application that is installed on your Kubernetes cluster, and it's using a Kubernetes API. Well, it's exposing Kubernetes API to you, and you can define GCP objects as the Kubernetes objects, right? And then on the Kubernetes, you have a controller that's talking to GCP API and does provision all those objects for you. Whether it's something you should be using, I think is a very early stage. This is probably going to be very useful if you mainly want to focus on Kubernetes and you also want to provision resources that your Kubernetes application will use. So for example, you want a Cloud SQL database, so you can actually provision your application and provision the SQL database using Kubernetes API. But this is in progress. I think this will be pretty popular. But again, an alternative for Terraform. The Terraform basis. So as I was saying, Terraform is open source, but you also have an enterprise edition that you install on-prem. And this is actually very useful when you have a big team and you want to have one place, have an API to talk to Terraform, because otherwise you need to run Terraform from a CLI. It doesn't have an API itself. You need to have this. So it's kind of like Ansible Tower, if you know Ansible Tower. So it's a one workspace where you can collaborate. It's more for enterprises where you want to have role-based access controls. You can actually achieve this using other automation tools. So you can, for example, use Jenkins and call those Jenkins pipelines. But it very much depends on your use case. Yes, maybe it's an alternative for you. And you also have this cloud version, which is basically enterprise version that's delivered to you as a SaaS software. Okay, a couple of versions that are available right now, and you will see that Terraform 11 is still there. We see most of our customers are actually using Terraform 0.11. I would say the most stable one is 0.12, and there is a new version 0.13 that's GA already. I think it was a couple of weeks or months ago that it has arrived. We've seen that there might be some breaking changes between those versions, so be cautious. We are planning to migrate to 0.13, but also be cautious that some templates that you have from Google that are available, for example, Cloud Foundation Toolkit, is not yet, I believe, compatible with 0.13, and that's on the roadmap. And I think recently there was a beta announced for Terraform 0.14, but definitely something that you can test in development, but not in production. Okay, the first step with Terraform. How do we actually work with Terraform? So you define your Terraform templates, then you run Terraform init command. And this is what it's actually doing. It checks your templates, see all the providers that it requires, downloads the provider locally so that you can run your templates. The Terraform plan is actually going to show you which resources you will be provisioning. So it's going to change all that. It's going to show all the changes that you will make to your environment. Yeah. So you don't just run Terraform apply with some sort of force and you just blow up your environment. You can plan it. You can see what changes will happen. Obviously, you need to be very cautious, and I would never suggest you to apply to production directly. Even plan and apply to production always do tests in the test environment. That's what we do. We never plan and apply directly to production. Always use development and test environment, especially that you can spin it up quickly and delete it afterward. Okay, what are the files? So this is, you know, you can definitely have more files. You can have a different structure, but basically you have this main TF file where you define your template. You have the provider where you define the provider. Well, actually, I think you could actually keep them together, but you know, the best practice would be to have it separate. You have the variables where you define all the variables for your Terraform templates. You have the Terraform TF state file. This is where the state of your environment is kept, and you have the output file. So the output file is actually showing once you can define in the template what outputs you want to see, and this is very useful for showing, for example, IP addresses, or I don't know, for testing, for example, that you can take those output and test them. Actually, Tomek is going to show testing later on. Providers. So again, providers. It's not only that there is only Google provider. You also have, you know, providers for other clouds. You actually have providers for Kubernetes, I believe. You know, so you can automate a lot with Terraform. So I suggest you just go, you know, to Terraform IO docs providers, and you see all the providers that you have. You have providers for VMware, for on-prem stuff. It's massive, right? But what we use is the Google provider, and you know, when you use the Google provider, you have almost all the resources or all the services that are GCP. It can be automated, and Google is making really big effort, because we had to make this choice whether we go for Terraform, and one of the rationale why we are using Terraform is that actually there is a commitment from Google to deliver those templates. State files and logs. This is pretty important. So you don't actually want multiple developers to work on the resources. So you have something which is called the state file. Actually, with Google, it's pretty simple because it's using GCS, so Google Cloud Storage bucket, and it's actually storing the state, and it's making a logs. It's basically keeping the state of your resource, so that you know when you apply again or you plan, you see what changes will be made and what is the current state of those resources that you're going to apply the changes to. And also you have this log, so that you know multiple people cannot do actions on those resources at the same time. I'm not sure if that's changed for AWS, but I remember for AWS you actually needed to use NoSQL database for keeping the state. Okay, the modules. So the modules are basically like sort of a function. So if you want to put multiple resources in one place, or you want to reuse it, then you would use modules, and you can refer to those modules. They can be either local, so on your drive, or they can be remote. So we can put all those together and make it easy to deploy the whole infrastructure. So as an example, you might have, you know, multiple instances and a load balancer. So we can put it all together and deploy as one thing, and repeat that in future. Cloud Foundation Toolkit. So this is really cool stuff when it comes to Terraform. So this was actually first delivered for Deployment Manager, and you were able to just grab all this automation that Google has developed for your landing zone, for defining the environment for your workload, and just deploy it. Obviously, it doesn't fit all the purposes, but at least you had some foundation there. And fortunately, Google actually started developing the Terraform. This is actually saving us a lot of time as well, because they have their opinionated way of how the landing zone should look like. Well, that's one thing, but and it's according to their best practices, right? So if you want to be on a safe side and work with the Google best practices, you don't have your internal, you don't know how to set this is going to provide you with the templates that make this secure. They actually, for some, for example, for some of the deployments, they actually do validation against ForSeti policies. So there is something called Terraform Validator. So they actually would run it and check that their code is according to the policies that they define. And now you have around, probably it's bigger now, but it was recently when I checked that you have like 45 Terraform modules. Yeah, so it's I remember a while ago when we've been deploying OS patching, which is quite a new service. Well, it was beta, now it's GA, but we have seen that actually the modules have been created. So when we've been delivering this, there were no modules, and after 2 weeks, oh, the modules are there. So that's why it's worth coming back to the provider documentation and see maybe the module is already there. Okay, and with that, I think we'll switch to the demo. So Tomasz, the floor is yours. Are you able to share your screen?
Yes, let me try that. Can you put it also full screen? Since it will be easier to see what I'm doing.
Yeah, definitely. I stop my screen.
Okay, I don't think my screen is visible yet.
I don't see it yet.
Let me stop and start again.
Okay, I need to add it to stream. Okay, now it should be fine.
Just to confirm, can you see it already? So let's start by installing the Terraform. Terraform can be found on terraform.io. In the section download, you can find it for different flavors of your OS system. And there's also getting started section where you can find the tutorial how to install that. It's pretty straightforward, but if you do it for the first time, you can find some help over here. What I'm going to do, I'm going to utilize the Google Cloud Shell where the Terraform is already installed. Let's verify that. We've got that in version 0.12. Perfect. My folder is empty, so let's open Cloud Editor, create a new file. Let me call that main.tf. .tf is the default extension for Terraform, and let's specify the provider. The provider I'm going to use is Google, and I'm going to specify the project on which I'm going to work, which is devfest-tom. All right, that's it. What we can do right now is to initialize our Terraform environment with Terraform init. It will download the provider, make sure everything is all right, and we've got a success message. All right, so let's create some resource. The first one I'm going to do, I'm going to create a VPC network. For that, I'm going to use Google Compute Network, VPC Network, specify a name. Let's call that DevFest Network. And that's pretty much it. What I can do right now is execute Terraform plan to see what will be the plan of the action. As you can see, one resource would be added, which is VPC network called devfest-network, and Terraform apply to apply the changes. I can review them again. If everything is okay, accept that with yes. And the VPC network is being created right now. As you can see, it takes less than 1 minute in my example. And if I navigate back to Google Cloud Console, to VPC networks, we can see that besides our default network, there's another one created called the DevFest network. So that's pretty awesome, right? Just 7 lines of code and we've got our VPC network. There's also Terraform TF state file created, which hosts the state of our Terraform deployment. Terraform state can be kept locally or, for example, on the Google Cloud bucket. All right, let's do something more fun. Let's create the VM instance. I will call that VM1, specifying the name, machine type zone, boot disk with the image name, and also the network interface. The network, I'm not going to use the name. Rather, I will specify the reference to the object I already created. This is pretty cool because that will create a dependency that my VPC has to exist before the VM can be created. Let's apply the changes. As you can see, we do have one object to be added. That's our VM instance. We can review all the changes. And once accepted, let's specify yes to accept the changes. And the VM is being created right now. After around 15 seconds or so, the VM is created. So let me navigate to the Google Cloud Platform, to Compute Engine VM instances, and let's verify that. All right, there's our VM called VM1 with internal and external IP address. Everything seems fine. You can also modify your resources by changing the file main.tf. So in this case, I will add startup script that will install Nginx. To apply the changes, I will execute Terraform apply again, and it's important to understand what will happen. In this case, this change requires to recreate the VM, so the old VM will be replaced with the new one that will run my startup script and install Nginx web server. Let's accept the changes. As you can see, first the VM is being destroyed. Once it's destroyed, a new one is being created. So let's verify the changes. Let me go back to my VM view and refresh the page. There's a good chance that the IP will be changed since that's the different machine. Let me copy the external IP address. And if we try to access our web server, it will fail because there is no firewall rule that allows port 80 to be accessed. So we can add the firewall rule creation to our Terraform template as well. For that, I will use resource Google Compute Firewall and create a rule that allows HTTP traffic. Let's call that allow HTTP on our network. Again, instead of specifying the name, I will reference to the one we created previously. So that's the one. And let's create an allow section with protocol TCP and port 80 for HTTP traffic, right? Okay, the allow section is okay. Let's specify for who that will be opened. I will add the tag called web, and yeah, my resource definition is alright. So let's apply the changes. Again, in Terraform apply command, we can review the changes before we accept them. As you can see, one resource will be added, which is our Google Compute Firewall rule. Let's accept the changes. And after a couple of seconds, the rule is created. But there's one more thing we have to do. Since the rule applies to all the Google Cloud resources with network tag web, we have to make sure that our instance have this tag assigned. So let me add the definition of the tag, tags, and specify just one web. So that will modify our VM. Let me go back and again apply the changes. This time, since we just adding the network tag, it will not require VM creation. The whole changes will be done in place, so the VM will be online all the time, nothing will change. The only modification will be adding the web tag. So let's apply the changes. And after a couple of seconds, the changes on VM should be applied. And once this is done, our web server should respond. So let's verify that right now. Let me navigate to the tab with my web server, refresh, and we can see welcome to Nginx start page. One of the beauties of working with Terraform is that we can create everything with like a single command and destroy everything with single command. So in this case, Terraform destroy, we can review what will be destroyed. We've got three objects, which is VPC Network, VM, and Firewall rule. If we apply the changes, notice that first the Firewall rule and the VM instance is being destroyed. Once those two will be destroyed, then Terraform will also destroy VPC Network. The order is important, and Terraform keeps track of it thanks to the dependencies. If we would try to delete the VPC Network when it's being used by the VM, it would fail. So let's verify the changes. The VM instance doesn't exist anymore. And if I navigate to VPC networks, I can see that only default network exists. The one we created is destroyed. We can deploy the whole environment again with just single command, Terraform apply. We can review the changes. All three resources will be used. And since the dependencies were specified, Terraform will create them in the correct order. And after a minute or two, we should have all our resources up and running again. So hopefully that was a nice demo to show you what is possible with Terraform. Thank you. All right, as you can notice, I had that pre-recorded because it would take us a little bit longer. Some of the resources needed like 2-3 minutes to provision. That's why, to spare some time, I had that in form of the video.
Awesome, thanks so much. No, sorry, go ahead.
No, back to you. Thank you.
Okay, in the meantime, I see Wojciech has arrived. Great. Okay, so let me share my screen again. I see in the meantime that there was a question related to best practices. So yes, there are best practices. If you look for Cloud Foundation security blueprints on GCP, you will find the really nice document that's defining all the best practices from Google, how to set up a landing zone. Okay, now if you've seen that actually Tomasz, with the magic and beauty of internet, has created all this stuff within, I think, 3 minutes, right? Really great. It's going to take a little bit more, obviously, for you for the first time, but there is one help, really something that helped me a lot understanding how to write Terraform templates. Is actually something called Terraformer. And this is not official Google product. It's created by Waze SREs. And the funny fact is that actually I realized that Waze is a part of Google. So I think 2014 or 2000, yeah, I think 2014 or something like that. I don't want to invent stuff now, but they are part of Google, and they've been actually using, before they've been using, from what I learned, they've been using AWS, and they migrated everything to GCP, obviously, because of many reasons. But they have created this really cool tool. You can actually find it on GitHub, and this is supporting a lot of providers. So it actually supports all the major cloud providers: Google Cloud, AWS, Azure, Alibaba, DigitalOcean. It provides other platforms like OpenStack, and something really weird happened with this presentation, I just realized. But basically, it has a lot of providers. It actually works with Kubernetes as well, RabbitMQ, and more. So check what's actually supported. But basically, it's like a reverse Terraform. So it's actually taking the resources and bringing the resources to you as a Terraform template. So it's pretty simple to install. You just, on Mac, you just run brew install Terraformer. Then you do a couple of configurations. It's all explained on the GitHub, but basically a couple of steps and you have Terraformer installed. And with that, I'd like to show you a demo of this, how it works. I also have it recorded because obviously we want to save some time, but this is how you use it. So first, once you go through all the steps, you have Terraformer installed. You need to initiate it because it needs to understand which module is going to use. So for this purpose, you just create a simple init.tf file. And here you define the provider, and you just save it, and then you will run a Terraform command to initiate it. So the plugins are being downloaded. You have the Terraform initialized, so, and you're ready to go. If you're just going to use the Google Cloud Platform provider, you're good to go. Okay, what you do here, you see that you need to run. You you run this again. Yeah, so you need to export this provider as a environmental variable, and then you actually need to download the provider again. And now we're gonna import some GKE resources that already exist. Yeah, so you define which resources you want to download. You can download all the resources, but here we've been actually wanting to download the GKE and GCS. So we added GKE and GCS, and this is connecting to your project via API, and you can see that already the Terraform templates have been created here. So you can go inside and you see that the templates are there. You actually get all the resources that are related as well. So you could literally take it and deploy it somewhere else. Maybe you want just to change some naming in there, but basically you can download it, and it's very easy to learn Terraform this way. So you have something already deployed, and you just use Terraformer to get these resources back into Terraform templates. See, you have the providers, and you actually have the state generated as well. So you could actually manage those resources from here as well, the already existing resources. Okay. So this is the demo. As you see, it's very simple. Try it yourself, and it's a really booster to start playing with Terraform. Oops. See, I had this. And the next topic is Terraform testing, and I think we will switch to you, Tomasz, right? So let me stop sharing.
All right, I think I still share my screen, if you can put that. Yeah. Okay, I think it should be good. So let's go. So let's talk about testing. Why do I need to test? Just like in a software development, the fact that something compiles doesn't mean it's working. And it might be exactly the same story in infrastructure as code. The fact that you've got your Terraform code written that deploys different resources, different components, and creates your infrastructure, it doesn't mean that the infrastructure as whole will work correctly. It doesn't mean that each building block will work correctly with each other. And that's why you need testing. You can do that, of course, manually, but your infrastructure as code is going to be much of a living product, which will change in the future. And there are going to be a lot of different changes, some small changes, some added functionalities, etc. And to test that manually on each step might be painful. And that's why you can introduce automated testing. You can introduce them even in your CI/CD pipeline to make sure that with each commitment to your source repository, tests are run. So whenever there's an issue, you will catch them as soon as possible. Let's talk about type of tests. There are pretty much three types: unit, integration, and end-to-end testing. Unit tests are like testing the single unit, like the smallest piece of your code, the smallest functionality. For example, storage bucket creation. Integration test is testing couple of at least two units working together just to make sure that the cooperation is successful. For example, storage bucket creation and uploading files to that storage bucket. End-to-end tests are the most complex one, and they depend on the scenario. If you've got a workflow that utilize a couple of units that have to work together, that's a good example to create an end-to-end test for that. And all three types of tests, like unit, integration, and end-to-end tests, can be deployed or developed in Go language using TerraTest library. With TerraTest, you can automatically deploy your infrastructure, validate the infrastructure, and then undeploy it. So what will happen in the workflow? Everything that you want, for example, single unit for unit tests can be deployed. Then based on your design, tests or many tests can be run. then the infrastructure will be cleaned up, so your resource will be destroyed, and then you will have your result. Either the test pass or it doesn't. If it doesn't, you get the output, what went wrong. And let me show you that on the demo. I will show you a simple unit test demo. For that, I developed a simple module called bucket with main.tf that utilizes 4 variables to create a storage bucket. There's variables.tf with the definition of those. 2 of them, location and storage class, have some default values. And 2 of them, bucket name and project ID, have to be specified. I also have a file called outputs.tf that will produce the bucket name once the module is deployed. There's also a folder called test data with file bucket.tf vars that specifies 2 values that will be used for my testing purposes. There's a bucket name and project ID. And there's also my automated test written in Go with definition of test my bucket function. As you can see, it has module location and test data location. There are different stages: to clean up, to deploy, and to validate. And the validation, I suppose that's the most interesting one. Having a unit test that just deploys the resource and then deletes that and doesn't check anything, it's not really a test. So in this simple example, I have a test to validate if the name of the bucket that was deployed is the same as expected. In this case, I've got the bucket 12, and in my definition, there's a bucket 1. So I suppose the test will fail, but let's check it out. Let me run the test and look closer at what will happen. The first, the Terraform is initialized, apply is complete, and then destroy is also complete. So we've got all 3 phases. Let me go it from step by step again. First of all, the Terraform initialize and apply is complete, so that's deployment. Then we've got our output and the destroy, so the cleanup is also completed. And at the end, we see what was the result of our test. As you can see, it's failed because the name expected doesn't meet the name required. So let me fix my test definition and let me change the name of the expected bucket name. And let's rerun the test again to see what will change. Since that's just a single bucket creation, I don't expect tests to run too long. And as you can see, again, the resource was applied, destroyed, and this time validation went okay. The result is pass because the name meets the required name. All right, so I hope with that simple demo, I gave you a taste of what's possible with TerraTest. There's an official GitHub repository where you can find quite a few examples if you want to try to develop your own tests. And I, of course, encourage you to do so. All right, so thank you for your attention, and let me go back to our presentation. All right, so we are close to finish. We've got 2 more slides. First is how do I learn? I'm not sure, Konrad, do you want to take over?
Yeah, so guys, you probably want to learn more about GCP and learn more about how to automate GCP. So there are a couple of ways to do that. I really encourage you to look at Coursera, Quick Labs, and Pluralsight's website and on LinkedIn, because very often it occurs that you can have like half a month of time free of courses, or you can get some free Quick Labs. Actually, we also had a chance to offer free Quick Labs for the members of GDG. So have a look at that. And obviously, we have this contest today, so we'll be giving away the book I wrote with my colleague Brian Gerard. And well, try it. Yes, download Terraformer, play with Terraform. You have the free. You actually have the free tier on GCP. Play around with it. The easiest way is to actually use to learn GCP itself is Quick Labs. I'm not sure there are actually any Terraform labs. Actually, they should create it. Maybe they are. If they are, put it on the chat if you found it. But start playing with it, and then with the free tier, you can try playing with Terraform. So we really encourage you to do that. And I think with this, that's it. Unless we have some questions, guys, from you. Trying to have a look at the chat. So, yeah, there were some questions related to migration from, yeah, so I think basically Terraform is really good for setting up your infrastructure in a streamlined way. So, when it comes, I wouldn't, the Terraformer is pretty cool to copy stuff. I think it's still a little bit risky to download, to basically take over the responsibility of, well, take the existing infrastructure under Terraform. It can, there might be some issues with it, yes. But to learn it, to maybe create new resources, you can actually create the infrastructure manually, test it, and then use Terraformer to download it. Don't try to migrate it. Don't try to take over the infrastructure that you already have under this Terraform plan, because weird things can happen, yeah? Or if you do it, just please do it in development first and test it properly, because otherwise, you can blow up things. Okay, managing cloud infrastructure with Terraform. Okay, so I see there is a quick lab, right? Awesome, cool. So if there is a quick lab, you should definitely try it. Okay, I don't think we have any more questions. I'll check with Wojciech whether we want to start. We want to make a 15 minutes break. Let me check, guys. Okay, guys. So Wojciech, I suggest we take 5 minutes only. Grab a quick coffee. Let me put you in the stream and unmute you. I think you're muted, Wojciech.
Yeah, all good. Do you hear me?
Okay, cool. So guys, let's take 5 minutes. We meet in 5 and Wojciech can start with the next session. If you're guys okay, if someone, let us know.
Okay, then we see
In
each other at 5.
Okay, awesome. Talk to you guys in 5 minutes. Okay, guys, Wojtek, I think I can hear you already. So, guys, we'll start now. I'm really happy to have Wojtek here. We've been working on similar technologies in the past, and we're working on the same technology right now. So,
Indeed. So we evolved with technology. It's inevitable. You have to do it if you want to stay on top, right? So this is our daily work. But it's as well super cool stuff, right? Those fancy advanced stuff. And Konrad, actually, I started working with Terraform as well a little bit, playing. This is super cool. I love it, and it works with VMware as well.
yeah, it does.
So yeah, good stuff.
Yeah, we do actually Ansible with VMware, but Terraform is really cool. I especially see a lot of people, a lot of customers demanding Terraform. Google, they push on Google to develop the provider, and we see, like as I was saying, every week you go there, we have a new module available. So pretty cool stuff. But okay, let's get to the point, because I guess there are a couple of people that came here to understand what's this really cool new VMware Compute Engine feature. So the floor is yours. I'm really excited for this meeting. So go ahead.
Thanks a lot. I'm really happy to be here. Thanks a lot for the invite. My name is Wojciech Marusiak, and this is our agenda for today. As I'm a technical person, I want to spend less time in slides because it's not fun. And what I want to show you today is a bit of more demo. What you see, what you get basically when you try when you want to try it out, Google Cloud VMware Engine. Let's start it. Very shortly about me.
Sorry, Wojtek, I need to move you to the stream.
Okay. Let me open YouTube and let's see if it works. Okay. I think it works now. Brilliant. Okay. I'm a customer engineer at Google Cloud. I have experience with mostly infrastructure. So in the past, I worked with VMware technologies, server, hardware, storage, everything around VMware. And since 2017, I fell in love in the public clouds. And I'm at Google. I mainly have customers with infra modernization, so migrations. How can we move the VMs to the cloud? But as well, a huge part of my daily job is Google Cloud VMware Engine. You can find me in many different social medias. You can write me email as well if there are some additional questions. Feel free to do it. I'm open and I'm always happy to help. Next slide. So why? So there are different ways how you can migrate. There are different things you can migrate somewhere, right? And there are as well different reasons why you want to migrate your applications. Probably VMs are no longer that important. Our applications, so set of virtual machines, set of the services we consume. We want to migrate them, right? And it's not always easy. It's some applications are there might be some compatibility issues. There might be applications we don't know what they actually do, right? We all know those VMs, which basically there's always a screen test, right? If we shut it down, we know who uses this VM, right? So this happened in the past. And it's not easy to move those VMs to the cloud because there's probably owner might left the company, right? And as well, those migrations might be disruptive. If you think about re-architecting the environment prior to migration to the cloud, doesn't matter which cloud, right? it will take time. It's really time consuming. You have to find application owners. You have to know which virtual machines, which applications they talk with each other, right? And so it's not that easy. And the migration to the cloud, it's as well. It takes some time to upskill the people to gain the knowledge about the cloud. And it's not easy, right? With cloud, there's of course there's security, there's everything is there, but we have to learn how it's done. We have to adjust our processes, our services, and to run it there smoothly without any issues, right? And this it's not that easy, and therefore. It always depends. So the best answer is it always depends. Why do we want to migrate? When do we want to migrate? And what do we want to migrate? Right? Where GCP fits into the migration story? So there's this well-known approach or well-known chart, so to say, how and where we could migrate. And of course, it takes different effort and time to do it. Today, I want to focus on the lift and shift migration with Google Cloud VMware Engine. There are as well other options which you can utilize if you are if you can optimize prior to move. So perhaps different destination of your migration might be suitable. So, for example, Compute Engine or any other or any other service like Kubernetes or Antos, right? Today we will focus on VMware Engine part. So what consists? So what do we? I don't say sell. What do we offer to customers here? So we offer at Google. We offer managed. This. I think this is the most important. Managed by Google, sold and supported solely by Google. So there's no third party there, right? You just have one contract. I think it's important for if you have multiple invoices, if you have to contact different providers or different supports, right? Then it's cumbersome. It's really no fun working with that kind of technology. So with Google, you receive the fully verified and certified solution by VMware, and there are different parts of this solution. Let's skip this one. This is a sample comparison between on-premises data center and other cloud providers. Of course, it might differ. Of course, it might differ for you. The TCO might be different. Depends how you use your vSphere environment. If you have a specific use cases, if you have, for example, GPUs and you actively use them, right, or you host HPC, then this calculation might be different, right? But with working with different customers, GCVE is already pretty much 1 year old. Our first customer, so Deutsche Bank, they started and Deutsche Börse, they started to alpha GCVE beginning of 2020. So it's really a battle-proven solution. It's the GA, so general availability of the product was in June 2020. And since then, many customers started to use this solution. So with all the calculations, with all the TCO analysis we did at Google, we can say roughly 25% of savings can be done. It sometimes can be more, sometimes can be less, right? It depends, as usual. So what do you get? What do you get? I think it's the most important slide for today, right? Or maybe the other one. I will tell you which one. So what do you get? You get the standard. So the minimum purchase you have to do. So the minimum setup you have to have is a 3 nodes ESXi cluster. So it's a production one. We don't talk about one vSAN node host, right? it's doable technically, but this is a production environment, and you basically receive a very beefy host. So it's 36 cores, 768 gigs of RAM, and 20 terabyte all-flash NVMe storage. Cherry on the top is 100 gigabits per second fully redundant network. It's not only to the top of the rack 100 gigabit. It's as well to GCP and to the outside. So this is full 100 gigabits per second. It's not capped or something. You receive, you can use it. And so this is the host, right? Minimum is 3. You can have up to 16 hosts as of today, and this in one cluster. And this is a soft limit. If you require more, this can be changed with our product team. We are actually working on increasing those numbers, but it will come in the future. What else? You receive a fully managed vCenter server. You receive fully managed NSX and HCX. vSAN is, of course, included. This whole solution is based on vSAN. That's why this is why we have to have 3 hosts. This is the minimum requirement from vSAN. You receive as well. You get as well NSX-T advanced and HCX advanced as well. Which basically runs on those ESXi servers. As I mentioned, it's managed solution. So there is automated platform deployment. You don't have to basically do anything. You can just in the portal you just set it up, and it will be created for you. Of course, you can use the APIs from VMware. In case there's an issue with the host, there will be automatically added new host, and the affected or host with some issues will be removed from the cluster. And it's actually, you don't pay for it. You don't pay for this extra host, right? Which is, I think, cool. And what else? I think this is important as well to highlight this. There is many solutions, VMware as a service, right? But why customers choose Google to host their VMware infrastructure? It's actually access to other Google Cloud services, right? Because we have, for example, our superstar BigQuery, which is well known on the market for the data analytics, Antos, cloud storage, etc. So you get the full experience of Google, not only VMware part, but as well other services. You can connect, you can consume other services from your vSphere environment. And as I mentioned, Google end-to-end Google Cloud support. We at Google, we acquired a company called CloudSimple, which was basically the company, they created the automated deployment solution, and it's already integrated within Google Console and Google Cloud itself. Sorry. As usual, in every managed service or with every cloud solution, there is part which is cloud provider responsible for, and customer is responsible for as well. So Google's responsibility is the vCenter management, NSX, etc. So this you actually don't have to do anything there apart from creating networking segments in NSXT and creating virtual machines consume the service. And it's easy. It's a self-service, so to say. Yeah. How can we access this? So there are actually, it's not just one step. So clicking in the console, first of all, you have to enable API. So this is typical with in GCP prior to use the service, API must be enabled, which is easier part. And actually, to consume the VMware engine is you have to request a quota increase. Like with any other services at GCP, this quota must be within the limits. If you do, and it must be approved. So it works pretty simple. You just go to the quota settings and you just increase the VMware engine quota. Once approved, once your billing is okay, then no problem. You will receive the notification that it's there for you, and you can start consuming. So demo. I think this is the most important part. And yeah, let's see it. In my test project, I have access to the GCP, and I have quota of 4 ESXi servers, and it's as simple as going to the clicking VMware engine, and we will be basically redirected to the configuration page. We plan to integrate this fully into GCP console, so you won't be redirected somewhere else. However, it's on the roadmap. It will come. No worries. It's still easy to use. There's not much difference in terms of the experience. So once we are here, you have to create your private cloud. It's you just click and the deployment will start. So what do we do? So my private cloud was already created this morning. So I prepared my environment in advance. But it's as easy as clicking new private cloud. You just name your private cloud. You choose your location. No, actually, I cannot because I don't have enough nodes. But here you would see the different locations, and we will see the locations afterwards. There's a slide for that. And once you provide the seeder blocks for both of the vSAN and so the management stuff, and for HCX, once you provide those ranges, you just click review and create, and it's done. What's important? It's important to know that the deployment, so the deployment itself takes about 30 minutes. What do I mean by the deployment? 30 minutes is for just installing adding the host to the cluster, etc., and everything must be started, etc. So we can say safely around after 1 hour you have fully functional private cloud within Google Cloud VMware engine. Once the cloud is created, you can actually go there, and you have the basic information. So how many nodes? What is your storage capacity? How much cache do you have? vSphere version, NSXT version, etc. Where is it created? So all the pretty standard informations, and you can see the clusters here, subnets, vSphere related information such as vCenter server, FQDN, IP addresses, etc. So this is basically this is your environment. This is what will be deployed for you. There are some as well advanced vCenter server settings. You can actually launch vSphere client from here, and you can see the networking related stuff. So all components are visible, available for you. In this part of the portal, what you can do is you can actually configure the so-called regional settings. You can actually enable public IP addresses for your virtual machines. It's per VM configuration, and I actually did it in today. I have 2 virtual machines which are which have public IP addresses, and they can basically connect to connect to the internet. As this is a demo environment, we have some non-standard setup, so to say. So there's a different VPC which I don't have access to, and this is where we get those public IP addresses from. So and actually we have this edge services seed range. So this is where we basically connect our edge, and we provide the internet address to my virtual machines. But this is special use case. This is demo environment, so it's built a bit differently than, and then you would probably build your environment. And that's pretty much it, right? So there's as well some alerts, events, tasks, so typical stuff which we see in vSphere. So we see who created the environments, what was done. So pretty standard stuff which can be used for auditing. So nothing fancy. It's there if you need to use it. Yeah, for sure. So we already I showed you the part where you create your environment, and where you basically can add nodes, remove nodes, etc. Let's switch to the real environment and see what's going on here. So actually, using Terraform today, I deployed about 500 virtual machines, and probably I killed my environment. So this is actually not good, and I didn't have time because it happened, of course, 10 minutes to my presentation. So I wasn't able to contact our support and basically restart the vCenter server. Let's ignore the red exclamation marks here, and we can basically browse through the environment, right? Let's pretend it's all operational. The hosts are probably disconnected because of the vCenter server services issue, which can be easily fixed by either rebooting the vCenter server appliance or restarting the service itself. Let's pretend the exclamation marks are not there. And what we see here is a typical vSphere environment, right? So there's no wow. There's no wow here. It just simply runs somewhere else, and somewhere else is actually at Google Cloud Data Center. As a bare minimum, as I mentioned, we received the 3 ESXi hosts, and in the environment itself. So maybe let me rephrase it. The environment itself is built in a way that you don't have full access to the vCenter server, or let's rephrase it again. Your access or your rights in the vSphere in the vCenter server are configured so that you cannot harm yourself. So, for example, you cannot disconnect the hosts. You cannot. What else? You cannot delete the disk, etc. So it's basically safeguarded by our experience, or by experience the Cloud Simple team, and now Google Cloud VMware Engine team, with the most important operations which are required to do the daily job. So create virtual machines, manage the NSXT segments. Do the configuration there. So all is there for you. And what is important, you can actually in the previous portal, you can actually elevate your permissions. What does this mean basically? Let's say I want to install a backup solution, right? Doesn't matter which company. You just basically create those. So I already elevated my privileges. You just basically click here, and you provide the time frame for how long do you want to elevate your privileges in the vSphere. Once it's done, you have in your environment you have full access in terms of you can configure extensions in the vCenter server, so you can add those solutions to the vCenter server, and this works. What else? You have a vSAN here. You are free to configure. You are free to choose the FTT. Of course, for as default, we have FTT 1. If you want to have more, if your workloads require FTT 2, I think you require 5 or 6 hosts as a minimum to provide this protection for the virtual machines, to better protection or better failure to tolerance for your workloads, for your virtual machines. So environment is there. As I mentioned, you have full access to NSXT manager. Why is this important? Other cloud providers might not offer you the same access to the NSX, and we actually had one customer, and the customer required access. They just wanted to create a static root, one static root, and they couldn't do it somewhere else. And just because of that, because this was so important, this basically made them their life a bit easier. And of course, other GCP services, they switched the provider to us, right? So I think this is important. So the full access to the management, to your resources. And I mentioned as well that you are kind of protected to not harm yourself. And in this cluster, for example, we don't see vCenter server, we don't see edges, we don't see NSX manager as a virtual machine. It's there, it's up and running. Where we can see it, actually in the NSX manager, we can see that those resources are actually there. We have 2 edges, we have H6 appliance, we have NSX manager highly available. So it's there for you. You just don't see it, right? Apart from NSX, there is a H6 Advanced, which can be used for the different types of the use cases. It can be a site pairing, it can be interconnection between the different data centers. It can be used for the live migration, so migrating virtual machines from one data center to GCVE without necessity to change the IP addresses. So it will be taken as it is in your location, and it will be migrated to GCVE. So it's there for you. You can use it. Yeah. So this is the environment. Let me switch back to the presentation because there are some other things which I think are important. Okay, so this is the kind of summary of our capabilities. What do you get? So the setup time is roughly 30 minutes. So this is just the deployment of the host. The full deployment 1 hour takes around 45 minutes to 1 hour. But I mean, it is important, but you don't delete your vSphere environment every day, right? So if you set it up right, then it's there, it's up and running. You receive quite beefy environment, so 36 vCPUs, 768 gigs of RAM, 20 terabytes NVMe storage, and 100 gigs, 100 gigabits per second, fully redundant networking. You can connect to your existing environment using options available from GCP, so Cloud Interconnect, Cloud VPN, or Partner Interconnect. Different ways how you can configure your on-premises networking together with GCP. You can consume other services from GCP by either VPC peering or private services access to different services from GCP. And you receive, there is a 4 nines support SLA for networking and storage, and for the infrastructure itself, so the management infrastructure is 3 nines. And of course, you receive the 24/7 first-party support from Google. yeah, you can, if you want to purchase it, you can consume it in 3 ways basically. It's pay as you go, so you just provide your credit card as a billing ID to your in your project, and you can actually consume you can run the service in pay as you go. So minimum 1 hour is just for the setup itself, but then if you just want to try it out for 2-3 hours, play with it, do a showcase demo, etc., it's doable. You can, of course, if you like the service, you can commit with a 1 or 3 years time period, and of course the price changes. Of course, favorable is 3 years. Depends. It depends, right? Okay. So those are the summary, pretty much slides. So you have the same experience as in GCP console. You have a unified connectivity to Google Cloud. You operate your environment in pretty much the same way as you did in the past. It's just a different vCenter. It's just different place for your virtual machines, right? And you can integrate with other services from GCP, BigQuery, Antos, operations, etc. So use cases. I briefly touched upon it. Use cases, of course, there are different. There are different environments, as there are different needs for customers, for your data center, it might differ. What we've seen so far at Google Cloud, we've seen several which are dominant, and let's start with the data center lift and shift. It's pretty much the most popular. Sometimes customer basically they want to get rid of their own hardware and they want to purchase it as a service. They don't want to manage anymore vSphere host, servers, rack, data center. So this is the most common one, and we consider it as a lift and shift or extension of your on-premises data center. The second use case is disaster recovery. There might be a need for certain customers to have second data center. For example, financial services, especially, they require second data center where they can, in case of disaster, they can move their workloads, so they can start the workloads somewhere else and can be up and running. So this might be the second use case. And actually, that's the beauty of the cloud and the as a service solution. You can purchase, you can have up and running 3 nodes environment, and if something happens in your primary data center, you can add more hosts to your cluster, and you can move the production to the GCP active data center, so to say. And of course, the other use cases like VDI, so work from home. I was actually working with one customer. It started in March. They didn't have enough capacity for their own VDI environment on premises, and we deployed. In that case, it was Horizon with on GCP. So and the customer was very happy. The solution pretty much worked as they expected. And they are quite happy. They still use it, and of course the other use cases which are not as that common. So application modernization, I would consider more probably Kubernetes approach or containerization approach rather than modernization on vSphere. It's doable, but why make your life more difficult to do it on vSphere once you can do it natively with other services, right? What's important to remember as well is that what you purchase, it includes the licenses as well. So there is a vCenter server license. The typical licensing. It means that you get the NS6 license, you get the H6 license, and you get the full vSphere license. Of course, you can use as well other solutions from the vSphere ecosystem. So Horizon, automation, SRM, operations, etc. You can use those, but for those solutions, they will definitely work. They are supported, but you have to first check if you can move the license from on-premises and you can run it somewhere else. But they will simply work. It's as in your existing data center from the operability and manageability point of view. As well, VMware ecosystem is quite huge. So you can use other solutions which are on the market. It can be backup solutions. It can be storage solutions, etc. You can as well consume. You can add to your GCVE environment. You can add additional storage. And why would you ask, right? We have super performant vSAN cluster. It's all flash and NVMe. Why would I want to add another storage to my cluster? The answer, of course, it depends. What are your requirements, right? If you want to have additional storage for a backup, right? Or if you want to store the virtual machines on a different storage, maybe you want to save your fast and performant vSAN and store those less performant virtual machines somewhere else, for example, on the NetApp or other storage solution available from the marketplace. It's totally okay. You can actually, in case of the NetApp, you can leverage the NetApp features you probably know from your on-premises environment. You can use the same features at GCVE or GCP. Once you add your data store, you can protect the virtual machines with the snapshot. So if something happens, you can very quickly restore your virtual machine. You can configure NetApp itself with a slower disk. So the NetApp solution itself, it works naturally in Google Compute Engine, and you have there you can add different types of the disks to NetApp to the pool, so to say. If you want to have a very cheap or the cheapest available option for your backup, you can add the standard disks from GCE and add those to NetApp appliance itself and add it as a data store via iSCSI or NFS to your GCP environment. So this can be an option as well. If you require, for example, a third location or the second location for your backups, if your backup solution, if your vSphere backup solution supports Google Cloud Object Storage, this can be an ideal solution for you in terms of the backups. As of now, I know Zerto is supporting this. Vim will support Google Cloud Object Storage within the next release, which probably will happen soon. And of course, as I mentioned several times, so you can consume other Google Cloud first-party native services. So this is the sample picture about the DR with Site Recovery Manager. Your SRM will be in two places, so in VMware, in GCVE, and of course in your on-premises. The replication can happen over interconnect or VPN, and once something happens, you can basically promote this site to be active site and consume the services. As I mentioned, different use cases. VDI, you can simply extend your VMware Horizon presence to GCVE, deploy the virtual machines there. Actually, with Horizon, it's probably easier than with the virtual machines itself, since you have just the golden image. You can basically deploy it somewhere else, so the deployment should be faster, right? H6 Manager, I mentioned it's there. It can be used. The requirement for H6 Manager is an interconnect, so partner interconnect or dedicated interconnect. Because of those networks should be performant, the migrations should happen over the performant network, and that's important for the migrations. As I mentioned, backup to object storage, so cloud storage, can be used with Zerto as of now, and different backup providers will either include this or they have this on the roadmap. This is a bit higher level overview of the NAP cloud volumes. So you simply purchase it via marketplace and add it to your ES6i host, and it's as simple as clicking it through the portal, adding it, and consume the services. I mentioned as well about the BigQuery. It's there. You can use it. You can consume the data you already have at the moment in your GCVE. It can be ingested, then the data can be so BigQuery basically can easily consume it. There's as well a nice offer from Google. If you would like to have a single pane of glass, so to say, you can install a Blue Medora pack from Blue Medora, of course, but you can install the Blue Medora pack to your vSphere environment, and you can see all VMware metrics or vSphere metrics in Google Cloud Operations, formerly probably all of us know previous name which is a Stackdriver. So it's there. You can see this. You can create some alerts, which can be useful if something happens in your environment. You want to be alerted about it. Then it's quite easy to do it. And the workloads itself. As a typical vSphere environment, you can run pretty much. Maybe let me rephrase it. If you can run it on VM, if it's supported if it's supported on vSphere, you can run it on GCP as well. So it can be you can run those the same applications you have. The same applications you have in your on-premises data center, you can run it as well in GCVE, and solutions such as Oracle databases, Microsoft SQL Server, and any other supported workloads from vSphere ecosystem and vSphere workloads, so to say. Where are we as of today in terms of the region availability? Those are the regions which are available. The closest to Poland is Frankfurt, and London, of course, depends where you live. The next one in Europe on the roadmap is Netherlands. It will either happen in end of Q4, so probably December, or Q1 2021. So it's coming, and for those customers, for those people who require multi-site environments, worldwide deployments, we are there. We are worldwide available, and actually we had one customer who was using the service in Virginia and in Sydney, and they did H6 migrations as well. So it works. It's vSphere based, so it simply works. If it's Virginia to Sydney, it of course the cable is longer, but it still works. Key takeaways. So what I wanted to highlight at the end, those are several things. I will say a bit about the future of the product itself. Yeah. So what I wanted to say here, pretty much at the end of my presentation, Google Cloud VMware Engine is quick to deploy and easy to manage solution in the cloud. Sorry. You can basically bring your VMware-based environment to the cloud without major modifications. Of course, it's different place. Of course, there are different things to consider. Different probably networking might be complicated at the beginning. So it must be well designed, well thought process. What do you want to move? We say it's easier move to the cloud, but it's always good to sit, take a step back, and do the assessment of my environment. Right? What do I want to move? Do I have to move everything? Do I have to re-architect something? Do I know which applications talk with each other? Right? So this is important. So without preparation, the migration will be not easy. You're probably going to fail. So good preparation is highly recommended. And at the end, what I wanted to highlight as well is Google Cloud VMware Engine is a first-party solution from Google, managed and supported and sold by Google. So you just get one invoice from Google. And that will be end of my presentation. I hope there are some questions. Konrad, do we have any questions? Are we still there?
Okay. I wasn't in the stream, so you probably didn't hear me.
Nope.
Okay, cool. So one of the questions is, VDIs will have GPU hardware acceleration in GCP solution? That's a question.
Yeah, good question. It's on the roadmap. I don't know if it's Q1 2021 or Q2. So it's probably next year, but without the date. We have those requirements from the customers, so we listen. Yes, it's on the roadmap.
Okay, cool. I actually have the question about this monitoring of GCVE in cloud operations. So this is what it needs, a special definitions. How does it work? What's actually reporting to cloud operation?
So once you install the Blue Medora pack, you will see basically in operations, you will see all vSphere metrics. As simple as that. So everything what you see in vSphere, you will have those metrics available in operations as well.
Mm-hmm. And this it's a marketplace solution. How does it work? Do you know if this is like a...
I will follow up on that. It's available to download for customers, and there is no additional cost for GCP customers.
Okay, cool. I'll just like to learn a little bit more how you install it, because I haven't seen any plugins in cloud operations, but I think you can actually use Blue Medora for multiple things, not only GCP, but
not only, exactly.
Okay, cool. Are we able to use GCE images in VMware? Oh, good one.
Once again, GCE.
So are you able to actually use the standard Google Cloud Engine images in VMware?
Nope.
I think it's a different format, right? But
yes, it's different. So we at GCP we use different hypervisors. So if you export it, convert, then probably yes. But who wants to do it, right?
Maybe some tools like Packer or something like that might help.
Perhaps.
Okay, Marek Gliński, how about the latency for workloads with Oracle and NetApp storage? Not sure.
Yeah, so it depends, right? You would have to simply create a proof of concept and try it out, right? As I mentioned, we have a NVMe flash as a storage on those hosts. So it is as performant as NVMe, right? So it's quite fast. But you would have to try it out without any input. We would have to really sit down and try to try to think about how to run it, and create a proof of concept. This would be the best way.
Okay, cool. And actually, there is we actually have a solution for that. If you want to probably set on the licenses on Oracle, there is a database hotel offering where you can actually have Oracle workloads. Well, they're actually running. As far as I know, you can really run this in GCP data center, right? It's a collocation very close with low latency. But the experience is almost the same, right? You have such a small latency, you have it so close that it's neglectable. Okay, cool. I don't really see more questions, so we probably will be happy to answer any questions you guys have if you put it in the chat later, or you can ping us on LinkedIn. So, okay, I think we will conclude with that, and let's start with some questions. I know, Wojtek, you have two questions. I have one. Maybe we'll start with the easy one. Mine is pretty easy. So, again, guys, I hope we can identify you by the names used here. So, I'm asking the question now, okay, and we're expecting the answer in the chat. So, okay, if you're ready, my question is around Terraforms, and I want to ask you, what is the newest GA version of Terraform? General availability. I'm not talking about beta. So I see there is I've been looking at YouTube that there is a small lag, I think around 5 to 10 seconds. So let's see if we get any answers. I'll repeat the question. What is the newest general available version, general available, not beta, version of Terraform? Okay, and we have Marek. So yes, it's 0.14. 0.14 is still in beta, guys. So congratulations, Marek. Contact me on LinkedIn. We'll send you over the book. Okay, and we have two more. So two more of those. If you study for the Professional Cloud Architect exam, that's a guide, I'm going to use it actually for my study because I need to recertify. So I'm going to read my own book. It's going to be fun. So guys, question from Wojciech now.
Sure. I actually recommend the book. I use it as well for my certification, so it worked. So the question, what is the minimum amount of the host which you require to run at GCVE? Is it 3, 5, or 6?
Okay. My fingers crossed.
So we have the first answer. Rajasilan got it right. I think it might be a delay, right?
Yeah, it is a delay. So in the studio, we see it a little bit later. So we need to look in the chat on. So yeah, okay, let's put it in the chat. So the answer is 3, right?
Correct. Okay, then the second question. The second question is, within GCV, is it possible to use additional storage? Is it yes or no? Still waiting.
Yes, I don't see the answer. I see the first answer.
Yeah, cool. Congrats.
Okay, so You agree, Wojciech? That's Łukasz Zawadzki.
Congrats, Łukasz.
Okay, awesome, guys, and thanks again, Wojciech, for accepting the invitation. A really cool session. I was really expecting that news. I'm really happy to see what I see here, because I like the flexibility of the solution, really. So you have, and we also believe in that we need to give the customer flexibility when we manage the solution.
Yep.
Otherwise, you're just blocking a lot of stuff, and some of the solutions are not usable, right? So this shared responsibility is really important. Good to see that, and I will be observing how it grows. I see already quite big interest of customers to use GCV. So I keep my fingers crossed for you as well, for all the engagements. Thanks a lot for accepting, and thanks, guys, for joining us. The next meetup, I think we will actually do next year, somewhere around 15. We will have a session about HML. I invite you all. And let us know, actually, what you think about moving those meetings to like 11 a.m. maybe during the working hours. So maybe we'll have, if it's okay, or you prefer to have those meetings at 6 CET. Maybe we'll play with it. So we won't see each other on a meetup this year. So it's funny to say in November, but I wish you all the best. Merry Christmas. Have a great New Year's Eve. And yeah, maybe we'll have something Hawk. Follow us both, GDG Warsaw, GDG Bydgoszcz on LinkedIn, to look for the new events. Thanks again, guys. It was a pleasure to be with you for this year. Thank you. Bye.
Thank you. Bye.